What is going on, everybody? It's Mr. Gustin. I'm still in the physics conference room. We've just talked about current carrying wires. We've talked about charges and the right-hand rule. Let's do a little math now, okay? I've got a problem for you. I've got a problem where I have a battery. The battery has a resistor in series with it, and then it's got this thin piece of conductive material attached, okay? Now, it's attached. It looks like there's a 5 amp current running through the whole circuit, right? It's all in series. They all receive the same circuit. That thin conductive material is 15 grams and is 15 centimeters long, okay? Now, I know, because I've witnessed it, this thing is hovering, all right? So I am seeing this thing hover stationary. It hovers above the ground when we have a magnetic field turned on, okay? Now it hovers. So if that's true, that means if I zoom this thing out, I would see this thin piece of conductive material hovering. That means the weight of the object and the electromagnetic force of the object would be equal, okay? I see this thing hovering. Now here's my question. If this thing hovers when I turn on the magnetic field, my question is, what is the strength and the direction of that B field? Okay? What is the strength and direction? The first thing, let's go ahead and just use our right-hand rule to figure out what the direction of this is. It's the right-hand rule. It's qualitative. I can easily do this. Let's figure it out. I have current flowing through this way. Current flows through this way, but it levitates off the ground, right? It's held upward. So I know the force is going to be upward, combating or working against to balance out gravity. So I've got current flowing this way. I have got a force that I need to push up on it with. So I'm pushing up on this thin conductive material while current goes that way. If I'm going to push up and my thumb points that way, my fingers have to point into the page. So I already know right now that my B field is going to be into the page all over the place. It's experiencing, the direction is into the page. Check, got that off my list. The next question I have for you is, well, what's the magnitude? What is the minimum force required to get this thing to hover stationary, okay? Well, if that's true, I look at my picture. I drew a forces picture because I'm a good student and I know to draw my forces picture. If that is true, I know that FB minus FG must be equal to 0 newtons. There's no acceleration. If it's hovering, it is stationary. There is no acceleration. These are balanced forces. So FB must be equal to FG. Let's go ahead and do some math. Fg is mg, mass of that conductive material, times baby g, which is 9.8. And then the force on a current carrying wire, the force on that is equal to the B field it is in, times the current running through it, and what is the length of the wire in that B field? Because if the wire is outside the B field, it's not going to experience a force. So whatever the length of the wire is that is inside that B field, that's what matters when determining force. Let's start plugging some things in, folks. I'm trying to find the value of the B field. The current I know is 5 amps, and the length of the wire is 15 centimeters, but that's not my base unit. I need to convert to base, so I need 0.15 meters. This is the magnetic force, or the electromagnetic force felt by that material. If it is balanced out by my gravity or the weight of that material, that means I need to take 15 grams, convert it into kilograms. 0.015 kilograms is the base unit, times 9.8 newtons per kilogram, because I'm trying to find force. If I go ahead and work this out, I can do my algebra, I multiply these, this ends up being close to 0.15, which is this is close, this is 0.15, so those will actually drop out. I end up with 1/5. My B field is really, really, really close to being 0.20. And what is my unit for B field? Capital T for Tesla. There it is. That's my equation. My B field, if my B field is approximately 0.2 Tesla and pointed into the page, I will get that thing to hover. So what's the answer? 0.20 Tesla into the page. That right there, that causes that thing to hover. This is an example problem for the second right-hand rule and for using our force equation or balanced forces equations. If you got questions, drop in the comments, send me an email, or ask me in class. Until next time, see ya.